All right, given that segment RQ and segment TS are congruent, and that those same segments are parallel, we want to prove that angles Q and S are congruent, given the diagram to the right here. Now, a quick note, when we say that RQ and TS are congruent, that is not the same as saying they are parallel. And when we say they're parallel, that is not saying they are congruent. This is two unique statements. They are completely different from each other. And that's important to know as we do proofs. You can't assume congruence off of parallel. You can't assume parallel off of congruence. For number one, just like we've done on numerous other proofs, we are just rewriting our given here. So we have RQ is congruent to segment TS, and segment RQ is parallel to segment TS. And this is given to us, so it must be true. Now, as you do a proof, you should always draw your diagram, and as we work, we want to mark our diagram. So we know that RQ and ST are congruent, so we're going to mark them as congruent. And we know that RQ is parallel to ST, and so we're going to, or TS, we're going to mark them as parallel. Those are the arrows here on the sides that marks parallel. The slash straight line is for congruence. When you see a diagram like this, you should always know a second step that you should be able to do. And if you can't, then start to look at the diagram here and note that there are two triangles that are formed. So it is a quadrilateral. Because of the segment going down the middle, then it gets cut into two triangles. And since that part is part of both of our triangles, a thing that will normally happen in a diagram like this is we are able to say that RT is congruent to segment RT. How do we know that a segment is congruent to itself? Well, that is the reflexive property. So now we have this segment congruent to itself. Now step 3 is a little bit tougher. It uses stuff that we haven't used quite as much, but it should be fairly fresh for us. So given lines are parallel in a diagram, anytime that we know that lines are parallel, we should be thinking about congruent angles. So what angles are congruent based on these two segments being parallel would be the angle up here and the angle down here. So this is angle, we cannot just call it R, so we're going to call it QRT is congruent to angle STR. So QRT is the angle up here, and STR is the angle down here. We know they're congruent because these two segments are parallel, and they are being cut by a transversal. That transversal is RT. These are both inside or between the parallel lines on opposite sides of the transversal. This is the alternate interior angles theorem. All right, and that should be enough for us to continue moving. We have two sides of one triangle congruent to two sides of another triangle, and the angle between those sides is also congruent. That means that we can state that triangles are congruent, and so we might say that triangle QRT is congruent to triangle STR. Now here you do want to be careful because you do need to get the corresponding parts set. So angle Q and angle S go together. You'll note that R from one of the triangles goes with T from the other, and T from the first triangle goes with R for the second. Now what allows us to say triangles are congruent? There are only 8 choices. So we are using side, 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 angle, side, angle, side, angle, 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 side. Those are our normal four, or the right triangle ones: hypotenuse, leg, hypotenuse, angle, leg, leg, and leg, angle. Now, we're not dealing with right triangles, so right away we can say, well, it's not these four. It's one of these other four on the left. It's either side, 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 angle, side, angle, or angle, angle, side. And we're going to use process of elimination here, or at least to help. So we definitely don't have three sides right now. We do have two, and given that we have two sides and one angle, not two angles and one side, you can say it's not either of those. So if it's going to work, right now it's going to be this one, side, angle, side, and we do have a side, QR, an angle, and then a side RT, and on the other side we have ST, angle, RT. So it is side, angle, side. Now you might ask yourself, are we done? Which is a good question to ask, but given that I'm writing number 5, the answer is no. We are not trying to prove that the triangles are congruent by themselves. It is just a means to the end of the problem. We are trying to prove that two angles are congruent. So how do we know those two angles are congruent? How do we know those two angles are congruent? Well, given that the two triangles are congruent, their corresponding parts must also be congruent, and here the order of the congruent statement in number 4 tells us the corresponding parts, that Q and S are corresponding parts, therefore they must be congruent. That is because corresponding parts of congruent triangles are congruent. That is CPCTC.